There is a region of the Atlantic Ocean that has swallowed more than 1,000 lives and absorbed more human speculation than almost any other place on Earth. It has no official boundaries on any maritime chart. No government has ever declared it a hazard zone. No international maritime organization has designated it as requiring special navigational caution. And yet its name is known in virtually every language on Earth, recognized instantly by people who have never been within 3,000 kilometers of it, who could not tell you its precise location on a map, but who know, with the certainty of a story told so many times, it has become indistinguishable from fact that something happens there. Something to ships, something to aircraft, something that the official record cannot fully explain and that the human imagination has been filling in with increasing elaboration for more than 70 years. The Bermuda Triangle. The name itself is a construction, a label applied to a region of open ocean between the southern tip of Florida, the island of Bermuda, and the archipelago of Puerto Rico. A rough triangle of water covering somewhere between 500,000 and 1.5 million square kilometers, depending on who is drawing the lines. Those lines are not fixed. They have never been fixed. The original formulation of the triangle was approximate, the boundaries shifting with each new account, expanding to include new disappearances, contracting when the evidence proved inconvenient. The triangle is, in one very real sense, a story about a place more than it is a place itself. But the place is real. The water is real. The depth beneath that water is real. And what has happened in that water, stripped of embellishment, examined with the same instruments and the same rigor that scientists bring to any other part of the ocean, is strange enough to deserve serious attention without any mythology attached to it at all. Tonight, we're going to give it that attention. We are going to descend through the history and the science and the geology and the biology of this particular patch of Atlantic to find out what the Bermuda Triangle actually is and what it actually contains. And what we find, I think, will be more interesting than the legend. If you could dive beneath the surface of the Bermuda Triangle tonight and keep going, how deep do you think you would go before you hit bottom? Tell us in the comments. If you enjoy drifting into the deep ocean and discovering what lies beneath, please consider liking and subscribing. It truly helps more than you know. Are you ready? Let's begin. To understand what the Bermuda Triangle actually is, you have to start with the geography, not the mythology. The region sits in the western North Atlantic Ocean, bounded roughly by 3 points: Miami, Florida to the west, the island of Bermuda to the north. Sitting isolated in the Atlantic, approximately 1,700 kilometers east of the U.S. coastline, and Puerto Rico to the southeast. If you draw a triangle connecting these 3 points on a navigational chart, you get an area of open ocean that includes some of the most heavily trafficked shipping lanes and air corridors in the world. Hundreds of thousands of flights cross the triangle every year. Thousands of ships transit it annually. It sits at the intersection of routes connecting North America to Europe, North America to South America, and the Caribbean to the mainland. By sheer volume of traffic, it is one of the busiest stretches of ocean on Earth. Any statistician would tell you, before examining a single incident report, that a heavily trafficked region will have more accidents than a less trafficked one. That observation alone does not explain away the Bermuda Triangle, but it is the essential starting point for any honest examination of the record. The physical oceanography of the region is extraordinary and genuinely unusual, and this is where the story gets interesting on purely scientific grounds, entirely independent of the disappearances. The most dominant physical feature of the Bermuda Triangle is the Gulf Stream, one of the most powerful ocean currents on Earth. The Gulf Stream originates in the Gulf of Mexico, flows northward through the Florida Strait between Florida and Cuba, and then curves northeast into the open Atlantic, eventually reaching Europe as the North Atlantic Current. At its peak, in the Florida Strait, where it is most concentrated, the Gulf Stream moves 30 million cubic meters of water per second. That is a number that is genuinely difficult to comprehend. The Amazon River, the largest river on Earth by volume, moves approximately 200,000 cubic meters per second. The Gulf Stream moves 150 times that volume. It is not a river. It is a continental-scale hydraulic system, a conveyor belt of warm water that regulates the climate of the entire North Atlantic and that crosses directly through the Bermuda Triangle. A ship or an aircraft that goes down in the Gulf Stream does not stay where it went down. The current moves it. Debris is carried hundreds or thousands of kilometers from the point of impact before anyone can search for it. A hull on the bottom is shifted by the bottom currents that the stream generates. Evidence in the Gulf Stream is mobile in a way that evidence on land is not. The seafloor beneath the Bermuda Triangle is itself one of the most geologically diverse and least explored sections of the Atlantic Basin. Directly beneath the western portion of the triangle, between Florida and the Bahamas, the seafloor is relatively shallow, a broad carbonate platform that rarely exceeds a few hundred meters in depth. This platform is the geological foundation of the Bahamas, an archipelago of low-lying islands and shallow banks built up over millions of years by the accumulated skeletons of marine organisms. The water here is clear and turquoise and warm, and the seafloor is sandy and relatively featureless. But move east from the Bahamas, cross the platform edge, and the seafloor drops suddenly and dramatically. The continental shelf ends. The water deepens from a few hundred meters to several thousand in the space of a few nautical miles. And in the southeastern corner of the triangle, directly north of Puerto Rico, the seafloor reaches a depth that most people have never heard of, that has never achieved the cultural recognition of the Mariana Trench, but that is, by any measure, one of the most extraordinary geological features in the Atlantic Ocean. The Puerto Rico Trench is the deepest point in the Atlantic Ocean. It runs roughly parallel to the northern coast of Puerto Rico and the Virgin Islands, extending approximately 800 kilometers in an east-west direction. At its deepest point, a location known as the Milwaukee Deep, it reaches a depth of approximately 8,376 meters. That is deeper than the average depth of the Pacific Ocean. It is more than 8 kilometers straight down in water so cold and under pressure so immense that the environment at the bottom has more in common with the floor of the Mariana Trench than with the warm, shallow Caribbean waters 50 kilometers to the south. The Puerto Rico Trench was formed by the same tectonic process that creates all deep ocean trenches, the subduction of one tectonic plate beneath another. Here, the North American plate is being pushed under the Caribbean plate along a boundary that is seismically active, generating earthquakes that have historically produced devastating tsunamis affecting the Caribbean and the east coast of North America. The trench is not merely a deep hole in the ocean. It is the surface expression of a tectonic boundary that has been shaping the geology of the entire Caribbean region for tens of millions of years. The existence of the Puerto Rico Trench, directly beneath the southeastern portion of the Bermuda Triangle, has implications that are rarely discussed in popular accounts of the region. A ship that sinks in 8,000 meters of water in the Puerto Rico Trench is effectively lost forever by any practical standard. The pressures at that depth, exceeding 800 atmospheres, are sufficient to crush most vessels into configurations unrecognizable from their original form. The cold and the darkness and the extreme depth make search and recovery operations essentially impossible with current technology. The biological communities that would decompose any organic material are active at those depths, operating slowly but persistently over the decades and centuries after a sinking. A vessel lost in the Puerto Rico Trench does not leave a wreck on the seafloor waiting to be found. It leaves fragments, scattered by bottom currents across a terrain that has never been systematically mapped in water that no human being has ever visited. This is not a supernatural explanation for disappearances in the Bermuda Triangle. It is a geological one. The trench is there. It is real. And it is deep enough to conceal anything that falls into it, permanently and completely, without any assistance from the paranormal. The atmospheric conditions of the Bermuda Triangle are another dimension of the region's physical reality that receives less attention than it deserves. The western North Atlantic in the latitude band of the triangle, roughly between 20 and 35 degrees north, is a zone of highly variable weather. The region lies at the intersection of several distinct meteorological systems. Tropical weather from the south brings warm, humid air masses that generate afternoon thunderstorms of extraordinary violence. With updrafts capable of tearing the wings of light aircraft and wave heights capable of swamping small vessels with almost no warning. Cold fronts from the north bring rapid weather changes, with conditions transitioning from clear to severe in hours or minutes. The Bermuda Triangle sits in the primary development zone for Atlantic hurricanes, the storms that form in the warm waters of the tropical Atlantic and track westward and northward, sometimes reaching Category 5 intensity, generating sustained winds exceeding 250 kilometers per hour and waves of 15 meters or more. The peak hurricane season, from August through October, corresponds exactly to the period when maritime traffic in the region is at its highest. The probability that a given ship or aircraft encountering a surprise hurricane over open ocean in the pre-radar era would have been able to send a distress signal, let alone survive, was not high. The compass behavior in the Bermuda Triangle is one of the features most frequently cited in popular accounts as evidence of something anomalous. A claim that circulated for decades held that the triangle was one of the few places on Earth where true north and magnetic north align, eliminating the need for magnetic declination correction. This claim is false. Magnetic declination in the Bermuda Triangle region runs between roughly 10 and 15 degrees west, requiring the same kind of correction as most other parts of the Atlantic. The zero declination line runs nowhere near the triangle. What is real, and what may have contributed to navigational errors in the pre-GPS era, is that the magnetic declination across the western North Atlantic changes significantly over relatively short distances, and that charts printed in one decade may carry declination values that are noticeably incorrect by the next, because the Earth's magnetic field drifts over time. A navigator using an outdated chart's declination correction in an area of rapidly changing magnetic field could accumulate a significant position error over a long open ocean passage. This does not explain crashes or sinkings, but it is a real navigational hazard grounded entirely in physics that the mythology of the triangle has both exaggerated and misrepresented. The methane hydrate hypothesis is one of the more scientifically interesting attempts to explain disappearances in the Bermuda Triangle, and it has been taken seriously enough by oceanographers to warrant examination. The seafloor of the Western Atlantic, including portions of the Bermuda Triangle, contains significant deposits of methane hydrate, a crystalline substance formed when methane gas is trapped in water under high pressure and low temperature conditions. These deposits are widespread on continental margins throughout the world's oceans. Under stable conditions, they are inert. But if the pressure drops or the temperature rises, the hydrates can destabilize and release enormous quantities of methane gas very rapidly in an event called a blowout. A large methane blowout on the seafloor could, in theory, produce a column of rising gas bubbles so dense that it significantly reduces the effective density of the water above it, potentially causing a ship to lose buoyancy and sink rapidly in a way that would leave little debris and no survivors. The methane bubble hypothesis was popularized in the 1990s and early 2000s as a physical explanation for sudden unexplained sinkings. Laboratory experiments have confirmed that sufficiently dense bubble columns can sink scale model vessels. Whether natural methane blowouts of sufficient scale to sink full-sized ships actually occur in the Bermuda Triangle has not been established. The geological survey data for the region does not identify any unusually high frequency of blowout craters compared to other methane-rich continental margins. The hypothesis is plausible in principle. The evidence that it has actually caused disappearances in the triangle is thin. The rogue wave phenomena is another physical mechanism that has been proposed as an explanation for unexplained sinkings in the Bermuda Triangle and elsewhere in the Atlantic. Rogue waves, also called freak waves or monster waves, are unusually large waves that appear seemingly without warning in conditions that would not predict them from standard wave models. For most of the 20th century, rogue waves were considered sailor folklore, stories told in port by men who had survived something inexplicable. The scientific establishment was skeptical. Then, on New Year's Day, 1995, a wave measuring 25.6 meters was recorded by instruments on the Drobner oil platform in the North Sea in sea conditions that should have produced maximum wave heights of roughly 12 meters. The existence of rogue waves was confirmed instrumentally. Subsequent satellite observations have documented dozens of waves exceeding 25 meters in the open ocean, in conditions where standard wave models predicted much smaller maximum heights. The mechanisms that produce rogue waves are not fully understood, but they include the constructive interference of multiple wave systems, the focusing effect of ocean currents on wave energy, and nonlinear wave interactions that can concentrate energy in unexpected ways. The Gulf Stream, which flows through the heart of the Bermuda Triangle, is known to produce rogue wave conditions when its currents interact with opposing wave systems. A rogue wave striking a ship from an unexpected direction, at a scale that exceeds the vessel's design limits, would sink it quickly and leave little trace. The wave would not be recorded. There would be no warning. The crew would have no time to send a distress signal. The ship would simply be gone. The blue holes of the Bahamas represent yet another physical feature of the Bermuda Triangle region that is rarely discussed in mainstream accounts, but that is scientifically extraordinary. Blue holes are underwater caves and sinkholes formed in carbonate rock, the limestone and dolomite that underlie the Bahamas platform. By the dissolution of the rock by slightly acidic groundwater during periods when sea levels were lower and the platform was exposed to the atmosphere. When sea levels rose at the end of the last ice age, these cave systems were flooded, creating the blue holes that are visible today as dark circular features in the shallow seafloor. Some blue holes extend only a few tens of meters in depth. Others descend hundreds of meters into vast underwater cave systems, some of the most extensive in the world, with passages extending for kilometers in multiple directions beneath the seafloor. The biological communities of the Bahamian blue holes are extraordinary, supporting organisms found nowhere else, including microbes with metabolic strategies adapted to the unique chemical conditions of these enclosed water bodies, which are often depleted in oxygen and rich in hydrogen sulfide below a certain depth. Dean's Blue Hole in the Bahamas, the deepest known marine blue hole in the world at approximately 202 meters, has been the site of free-diving records and scientific expeditions that have documented biological communities of remarkable diversity and strangeness. The blue holes are not a hazard to navigation, but they are a reminder that the seafloor of the Bermuda Triangle region conceals environments of genuine scientific interest and genuine physical danger for divers, if not for surface vessels, that the mythology of the triangle has almost entirely obscured. The oceanographic research conducted in the Bermuda Triangle region has produced data that is genuinely valuable for understanding the North Atlantic, entirely independent of the disappearances. The Bermuda Atlantic Time Series study, known as BATS, is one of the longest-running oceanographic monitoring programs in the world, collecting data on temperature, salinity, nutrients, and carbon chemistry from a fixed station near Bermuda since 1988. Research vessels have crossed the triangle hundreds of times without incident, mapping the Gulf Stream, measuring the depth of the Puerto Rico Trench, collecting sediment cores from the abyssal plain. The ocean here is not anomalous in its behavior toward vessels equipped with modern navigation. It is, for the most part, an ordinary stretch of the North Atlantic, with the same risks and the same complexity as any other section of open ocean at these latitudes. But the record of what happened here, before modern technology changed the terms of ocean navigation, is a record that deserves careful examination. And that examination begins with the cases themselves. The cases that built the legend of the Bermuda Triangle did not accumulate gradually over centuries. They arrived in a rush, concentrated in the mid-20th century, at a moment when aviation was new enough to be mysterious, and the ocean was still vast enough to be genuinely impenetrable to search. The legend was not assembled from ancient maritime records or medieval sailors' diaries. It was constructed largely by journalists and popular writers from incidents that were recent enough to carry the authority of living memory, but distant enough to have already acquired the distortions that memory and retelling introduce. The first and most important thing to understand about the Bermuda Triangle disappearances is that many of the most frequently cited cases are not what the legend says they are. The details have been altered. The contexts have been omitted. The mundane explanations have been suppressed in favor of the inexplicable. And when you go back to the primary sources, the official accident reports, the Coast Guard records, the naval inquiries, the newspaper accounts from the time of the incidents, rather than the accounts written decades later by people with a thesis to prove, a different picture emerges. Not a picture without mystery. There is genuine mystery here. But the mystery is more interesting and more honest than the version that has been sold. Flight 19 is the case that launched the legend. On the afternoon of the 5th of December 1945, 5 TBM Avenger torpedo bombers departed Naval Air Station Fort Lauderdale in Florida on a routine training exercise designated Navigation Problem Number 1. The aircraft were assigned to fly east over the Atlantic, then north, then southwest back to base, a triangular route intended to give trainee navigators practice in overwater dead reckoning. The flight leader was Lieutenant Charles Taylor, an experienced pilot with approximately 2,500 hours of flight time. The 5 aircraft carried 14 men in total. The weather at departure was acceptable, with some cloud cover and a stiff northeast wind. The training exercise was expected to last approximately 2 hours. None of the 14 men ever returned. A search aircraft sent to look for them, a Martin PBM Mariner flying boat, also disappeared that evening, taking 13 more men with it. 27 men and 6 aircraft were lost in a single afternoon and evening in December 1,945 inches the waters of the western Atlantic. By any measure, it was a catastrophe. And the investigation that followed was thorough, official, and in many respects deeply inconclusive. What the legend says happened to Flight 19 is that the aircraft flew into some kind of mysterious force field or anomalous zone from which there was no escape, that the pilots reported their compasses spinning wildly, that they expressed terror and confusion about having entered a world where things were not as they should be. The radio transcripts that survive from Flight 19 tell a somewhat different story. Taylor's communications with the base were fragmentary, affected by atmospheric interference and the limitations of the radio equipment of the time. What is clear from the transcripts is that Taylor became convinced, incorrectly, that he was over the Florida Keys rather than over the Atlantic east of Florida. This navigational error led him to fly north and then northeast in an attempt to reach what he believed were familiar waters, when the aircraft were actually heading out into the open Atlantic. The other pilots in the formation expressed confusion about Taylor's instructions. Some wanted to fly west, correctly believing that flying toward the setting sun would bring them over the Florida coast. Taylor, the senior officer and the designated leader, overruled them. By the time the base was able to establish that the flight was off course and heading in the wrong direction, fuel was running low. The 5 aircraft almost certainly ditched in heavy seas after dark when their fuel was exhausted. The TBM Avenger, an aircraft designed for carrier operations, was notoriously difficult to ditch successfully in rough water. It tended to sink within seconds of hitting the surface. In December, in the Gulf Stream, at night, in heavy seas, a ditched Avenger would have left very little trace. The Gulf Stream would have moved the debris rapidly. The search that followed was hampered by bad weather, darkness, and the immensity of the search area. The aircraft were never found. The navigational error that set the sequence in motion is documented in the radio transcripts. The tragedy of Flight 19 is not a mystery of the supernatural. It is a tragedy of human error in an unforgiving environment. The PBM Mariner that disappeared while searching for Flight 19 is another case that the legend treats as evidence of anomalous forces at work in the Triangle. The Mariner, designated Training 49, took off at 7:27 inches the evening on December 5 and was last heard from approximately 23 minutes later. It was never seen again. The legend implies that it too was swallowed by whatever claimed Flight 19. The more prosaic explanation is that the PBM Mariner had a well-documented problem with fuel leaks, which had earned it the nickname the flying gas tank among the crews that flew it. Fuel vapors could accumulate in the bilges of the aircraft, creating a hazardous atmosphere that could be ignited by a spark from virtually any source. A merchant ship in the area reported seeing an explosion in the sky at approximately the time and location where the Mariner would have been flying. The Navy's investigation concluded that the Mariner probably exploded in flight, most likely due to a fuel vapor ignition. The explosion would have been instantaneous and total, leaving no survivors and very little debris in the dark water below. This is not an anomaly. It is a known failure mode of a specific aircraft type, documented in maintenance records, explained by physics and chemistry, and consistent with a single piece of physical evidence available: the explosion seen by the merchant vessel. The Mariner was not taken by the Triangle. It burned. The USS Cyclops is the largest single loss of life in the history of the United States Navy, not directly attributable to combat. The Cyclops was a Navy collier, a ship designed to carry coal 165 meters long and displacing 19,000 tons when fully loaded. In March 1918, the Cyclops departed Barbados, bound for Baltimore with a cargo of manganese ore and 309 people on board. It never arrived. No distress signal was ever received. No wreckage was ever found. The ship simply ceased to exist somewhere in the Western Atlantic. The disappearance remains officially unexplained, and it is the most genuinely mysterious incident associated with the Bermuda Triangle, if the triangle is broadly defined to include the Western Atlantic shipping lanes. What the legend does not mention is the condition of the ship and its situation at the time of its disappearance. The Cyclops was operating with one engine out of service, reducing its maneuverability and speed. It was carrying a cargo of manganese ore, which is significantly denser than coal, meaning the ship was loaded to a draft that was at the edge of its design limits. The ship's captain, Commander George Worley, was under investigation for misconduct and was reportedly erratic in his behavior. Some accounts suggest the ship was structurally compromised. None of this proves what happened. But the conditions aboard and around the Cyclops at the time of its disappearance are entirely consistent with an ordinary maritime disaster of the kind that routinely claimed ships in the early 20th century. Before the era of radio distress signals, reliable weather forecasting, and systematic search and rescue, the mystery of the Cyclops is real. But it is the mystery of a ship that disappeared in 1918, in conditions that made disappearance entirely possible, not the mystery of a vessel claimed by supernatural forces. The story of Flight 19 and the USS Cyclops share a structural feature with most of the major cases attributed to the Bermuda Triangle: the absence of a recovered wreck. In the history of maritime and aviation disasters, the absence of wreckage is not unusual when the incident occurred in deep water, in strong currents, in heavy weather, or at night. The vast majority of aircraft that have gone down over the open ocean in the 20th century were never recovered. The vast majority of ships that sank in the deep Atlantic before the era of GPS and satellite tracking were never located. The Bermuda Triangle occupies an area of ocean that is deep, current-swept, storm-prone, and heavily trafficked. The absence of wreckage from incidents in this region is not a sign of anomalous forces at work. It is a sign of an ocean doing what oceans do, which is to conceal what falls into them. Charles Berlitz is the person most responsible for the Bermuda Triangle as a cultural phenomenon. In 1974, Berlitz published a book titled simply The Bermuda Triangle, which sold more than 20 million copies worldwide and was translated into dozens of languages. The book assembled the existing folklore around the triangle, added new cases, and presented the whole as evidence of a genuine and unexplained anomaly. Berlitz did not invent the concept of the Bermuda Triangle. The term had been coined in 1964 by a writer named Vincent Gaddis in an article for Argosy magazine. But Berlitz gave the triangle its definitive popular form. His book presented case after case of disappearances in the region, each one described in terms that emphasized the mysterious and omitted the mundane. Cases where the disappearance had a documented explanation, mechanical failure, human error, bad weather, were included alongside genuinely unexplained incidents without distinguishing between them. Cases from outside the triangle's boundaries were incorporated into the legend by expanding those boundaries to fit. Cases that were entirely invented or significantly embellished were presented as historical fact. The book is, by the standards of serious journalism or scholarship, a work of systematic distortion. But it created a story so compelling, so neatly organized around a geographical boundary and a pattern of inexplicable loss, that it became one of the most durable popular myths of the 20th century. The Bermuda Triangle that most people know is Berlitz's Bermuda Triangle, not the actual stretch of ocean between Miami and Puerto Rico and Bermuda. Lawrence David Couchet published a systematic rebuttal of Berlitz's claims in 1975 in a book called The Bermuda Triangle Mystery Solved. Couchet went back to the primary sources for every case Berlitz had cited, checking official records, newspaper archives, and naval inquiries. His findings were methodical and damning. Many of the ships and aircraft Berlitz claimed had disappeared in the Triangle had not disappeared in the Triangle at all. Some had sunk in the Pacific, some in the North Atlantic, far outside the Triangle's most generous boundaries. Some had not disappeared at all and had been located after the loss was reported. Several of the disappearances Berlitz attributed to the Triangle had occurred in violent storms that were well documented in weather records, storms Berlitz had omitted from his accounts. Some of the cases Berlitz presented as mysterious had been fully explained in official investigations conducted at the time. Couchet's conclusion was blunt. The Bermuda Triangle mystery is a manufactured mystery, the product of careless research, selective presentation of facts, and outright invention. The Triangle is not anomalously dangerous. It is anomalously famous. And what makes it famous is not the water or the weather or the geology. It is a story told with sufficient confidence and sufficient detail to feel like history, about a place where the rules of the physical world do not apply. That story is false in its particulars, but the place it describes is real, and the real place has things in it, beneath its surface, in its geology and its biology and its deep cold water, that are more extraordinary than anything Berlitz invented. The Ellen Austin incident is one of the stranger cases in the Bermuda Triangle legend, partly because it involves a derelict vessel, and partly because the version that circulates widely bears almost no resemblance to what actually happened. The legend holds that the Ellen Austin, an American brigantine, encountered an abandoned derelict ship in the Triangle in 1881, put a crew aboard to sail it to port, and then watched in horror as the derelict disappeared and was later found again, abandoned, with a prize crew gone. This story, repeated in Bermuda Triangle books for decades, is not supported by the historical record. The Ellen Austin was a real ship. It did encounter a derelict in the Atlantic in 1881. What the historical record does not support is the supernatural element, the repeated mysterious disappearances of prize crews. The story appears to have accumulated embellishments with each retelling until it bore little resemblance to the actual event, which was a relatively unremarkable encounter with an unmanned vessel in the open Atlantic. The Ellen Austin case illustrates the process by which the Bermuda Triangle legend was constructed, not from whole cloth, but from real incidents progressively altered by retelling until the mundane became mysterious, and the mysterious became inexplicable. The Star Tiger and Star Ariel were two British South American Airways Tudor IV aircraft that disappeared over the Atlantic in 1948 and 1949, respectively, and both are included in the canonical list of Bermuda Triangle disappearances. The Star Tiger disappeared on the 30th of January 1948 on a flight from the Azores to Bermuda, carrying 25 passengers and crew. The Star Ariel disappeared on the 17th of January 1949 on a flight from Bermuda to Kingston, Jamaica, carrying 20 people. Neither aircraft sent a distress signal. Neither was ever found. The British Air Accidents Investigation Branch conducted thorough investigations of both disappearances and reached the conclusion that the cause of the Star Tiger's loss could not be determined with certainty, but noted that the aircraft was flying in deteriorating weather conditions at the limits of its fuel range, that its autopilot had malfunctioned on a previous leg of the journey, and that its altitude had been compromised to avoid headwinds, reducing its fuel margins further. The Star Aerial investigation similarly noted that the aircraft was operating at range limits and in weather that had not been fully forecast. Both aircraft were Tudor IVs, a type that had a troubled maintenance history and that was eventually withdrawn from service. The investigations found no evidence of anything anomalous about the region. They found evidence of aircraft operating at the edge of their performance envelopes in conditions that were more demanding than the crews appeared to have anticipated. The Triangle did not claim the Star Tiger and the Star Aerial. The limits of aviation technology in 1948 and 1949, and the unforgiving nature of open ocean flying, claimed them. The pattern that emerges from a careful review of the cases is consistent and instructive. The incidents that make up the Bermuda Triangle legend cluster in the mid-20th century, not because the ocean became more dangerous in that era, but because aviation became common enough that aircraft losses over the ocean were newsworthy, and because the technological infrastructure for search and rescue was not yet capable of reliably finding wreckage in deep water. Before radar, before GPS, before satellite communication, before the era of continuous radio contact and transponders, an aircraft that went down over the open ocean could do so without leaving any trace that search parties could locate. The same was true of ships, particularly smaller vessels that could sink in heavy weather before transmitting a distress signal. The Bermuda Triangle did not become more dangerous in the 1940s and 1950s. Human beings simply began crossing it more often, in aircraft and ships that were pushed to the limits of their capabilities, in a pre-technological era when the ocean could still swallow evidence completely. The mystery of the Bermuda Triangle is, in large part, the mystery of what the ocean was before we had the tools to find what it took. And what the ocean contains beneath that surface, in the depths that those missing ships and aircraft may have reached, is where the real story of the Triangle lies. The statistical case against the Bermuda Triangle as an anomalously dangerous region was made most clearly by Lloyd's of London, the world's oldest insurance market. Lloyd's has access to maritime loss data on a scale that no individual researcher can match. When insurers examined the Bermuda Triangle as a potential risk category in the 1970s, the conclusion was straightforward. The Triangle does not carry a higher premium than comparable stretches of ocean. The United States Coast Guard, which maintains records on maritime incidents in American waters, has consistently stated that the region does not have a statistically higher incidence of disappearances than any other comparable, heavily trafficked ocean area. These are not the conclusions of ideological skeptics. They are the conclusions of institutions whose financial survival depends on getting risk assessment right. The Triangle is not anomalously dangerous. What it is, beneath the surface and beneath the legend, is a place of genuine geological and biological interest that the mythology has been obscuring for 70 years. And to find that interest, you have to go below the surface, much further below than most people realize. The Puerto Rico Trench is 8,376 meters deep. That number deserves a moment of attention before anything else is said about it. 8 kilometers straight down, in water that at the surface is warm and blue and visited by cruise ships and snorkeling tourists, but that at depth becomes something categorically different, cold beyond what most living things can tolerate, dark beyond what any light source we carry can illuminate, pressurized beyond what most materials we have ever built can withstand. The Puerto Rico Trench is the deepest point in the Atlantic Ocean, the deepest point in the entire Arctic-Atlantic basin, and one of the 10 deepest points on Earth. It sits at the southeastern corner of the Bermuda Triangle, running roughly parallel to the northern coast of Puerto Rico for approximately 800 kilometers. An enormous geological feature that the Bermuda Triangle legend has almost entirely ignored in favor of tales of magnetic anomalies and alien intervention. The trench is more interesting than the legend. It is older, it is stranger, and it is real in a way that the legend is not. The Puerto Rico Trench was formed by the subduction of the North American plate beneath the Caribbean plate, a process that has been ongoing for approximately 40 million years. As the North American plate dives downward into the mantle, it drags the Atlantic seafloor with it, creating the deep valley of the trench at the point of descent. The angle of subduction here is relatively steep, which is part of why the trench reaches the depths it does. The overriding Caribbean plate, by contrast, has been pushed upward by the collision dynamics of the boundary. Puerto Rico itself sits on the Caribbean plate, just south of the trench, on crust that has been uplifted and shaped by the same tectonic forces that created the deep water to its north. The mountains of Puerto Rico and the Milwaukee Deep are products of the same geological process, one pushed upward, the other dragged down, separated by the tectonic boundary that runs along the trench axis. The seismic activity generated by this subduction zone is significant and historically dangerous. The 1918 Puerto Rico earthquake, magnitude 7.1, struck along the Puerto Rico Trench and generated a local tsunami that killed approximately 116 people on the island's west coast. The 2020 Puerto Rico earthquake sequence, which included a magnitude 6.4 main shock in January of that year, also originated along the fault systems associated with the trench. Geologists who have studied the fault geometry of the Puerto Rico subduction zone have identified the potential for much larger earthquakes, possibly in the magnitude 8 to 9 range, that could generate tsunamis affecting the entire northeastern Caribbean and the east coast of the United States. The hazard is real, documented in the geological record of the region and ongoing. The Bermuda Triangle legend has never mentioned it, because geological hazards do not fit the narrative of mysterious disappearances. But the tectonic boundary that runs through the southeastern corner of the triangle is one of the most consequential geological features in the Atlantic basin. The biology of the Puerto Rico Trench is almost entirely unknown. The trench has been visited by deep-sea research submersibles on only a handful of occasions. The bathymetric mapping of the trench The systematic measurement of its depth profile using sonar has been conducted in sufficient detail to establish the location of the Milwaukee Deep and the general shape of the trench walls. But the detailed three-dimensional topography of the trench floor and walls is known only in outline. The sediment that has been accumulating on the trench floor for millions of years has been sampled at very few points. The organisms that live in the hadal zone of the trench, the zone below 6,000 meters, where conditions are most extreme, have been studied in only the most preliminary way. What is known is broadly consistent with hadal biology found in other deep trenches. Microbial communities of considerable diversity, amphipod crustaceans in large numbers, holothurians and polychaete worms in the sediment, and the slow rain of organic matter from the productive surface waters above, providing the energy that sustains this community. But the specific species composition, the degree of endemism, the physical and chemical conditions at the trench floor, the geochemistry of the sediment, these are almost entirely undocumented. The Puerto Rico Trench is, in this sense, one of the most significant unexplored environments in the Atlantic Ocean. The organic chemistry of the trench sediment is of particular scientific interest because of the enormous quantity of organic matter that the surface ocean above the trench produces. The Caribbean and western North Atlantic are biologically productive waters, their surface layers enriched by the upwelling of nutrient-rich deep water along the trench slope, and by the discharge of nutrients from the Caribbean island rivers. The marine snow that falls from these productive surface waters accumulates in the trench, concentrated by the funnel geometry of the trench walls, in the same way that organic matter is concentrated in other deep trenches. The trench floor receives more organic input per unit area than the surrounding abyssal plain, supporting a biological community that is, by hadal standards, relatively well fed. The microbial processing of this organic matter in the deep sediment of the Puerto Rico Trench releases nutrients back into the water column and cycles carbon between the organic and inorganic forms, a process that contributes to the chemistry of the Caribbean basin water. The trench is not merely a passive receptacle for the material that falls into it. It is an active chemical system, processing the organic legacy of the surface ocean in ways that have implications for the chemistry of the entire basin. The Gulf Stream, which flows through the heart of the Bermuda Triangle north of the Puerto Rico Trench, has a direct physical relationship with the deep water of the trench that is rarely appreciated. The Gulf Stream is not merely a surface current. Its influence extends to considerable depth, generating pressure gradients and subsurface flows that affect the water column throughout the western North Atlantic. At the depth of the Puerto Rico Trench, the direct influence of the Gulf Stream is minimal, but the thermohaline circulation that the Gulf Stream drives, the sinking of cold, dense water in the North Atlantic that feeds the deep water masses of the Atlantic, produces the cold bottom water that fills the trench. The water at the bottom of the Milwaukee Deep is North Atlantic deep water, formed at the surface of the North Atlantic near Greenland and Iceland by the cooling and sinking of surface water, which then flows southward along the ocean floor and eventually fills the deep basins of the Caribbean and the trenches that cut through them. The water at the deepest point of the Puerto Rico Trench has been separated from the surface for approximately 600 to 1,000 years. It sank near Greenland during the medieval period, circulated southward along the Atlantic floor, and arrived at the trench floor sometime in the past few centuries. It carries with it the chemical signature of the conditions that existed at the North Atlantic surface when it sank, a record of past temperatures and atmospheric carbon dioxide concentrations preserved in its dissolved gases. Reading that record requires sampling the water at depth, an operation that demands specialized equipment and considerable logistical difficulty in a location as remote as the Puerto Rico Trench. The number of systematic water chemistry measurements from the deepest portions of the trench can be counted on one hand. The data that exists suggests that the deep water of the Puerto Rico Trench is broadly consistent with North Atlantic deep water elsewhere in the basin. But the specific physical and chemical environment of the trench interior, shaped by its enclosed geometry and its proximity to the active tectonic boundary, may differ from the open basin in ways that have not yet been documented. There may be hydrothermal inputs along the trench walls that locally modify the chemistry of the deep water. There may be cold seep communities on the trench floor, sustained by fluids migrating upward through the sediment along fault planes associated with the subduction zone. There may be biological communities adapted to conditions that have no equivalent elsewhere in the Atlantic. The trench is 800 kilometers long and has been sampled at a few dozen points at most. Everything else is inference and extrapolation. The abyssal plain surrounding the Puerto Rico Trench, the relatively flat seafloor at depths of 4,000 to 5,000 meters that extends between the trench and the mid-Atlantic ridge, has been somewhat better studied, but remains largely unexplored by the standards of comparable environments on land. The sediment of the abyssal plain in this region is a mix of calcareous ooze, the compressed remains of foraminifera and coccolithophores that lived in the surface ocean, and red clay, the fine mineral particles that have been transported by winds and currents from the continents. These sediments have been accumulating for tens of millions of years at rates of a few centimeters per thousand years, building up a record of the ocean's history that is, in principle, readable by the techniques of marine geology. Sediment cores from the tropical North Atlantic have been analyzed for their paleoclimate records, their records of past ocean chemistry, their records of productivity changes in the surface ocean. These cores tell a story of the Atlantic Ocean over the past few million years that is rich and complex and that connects directly to the history of the regional climate, including the tropical storm frequency that affects the Bermuda Triangle region. The sediment record shows periods when tropical cyclone activity in the western Atlantic was higher than today, and periods when it was lower, cycling with changes in sea surface temperature and atmospheric circulation that are driven by variations in the Earth's orbit around the Sun. The disappearances attributed to the Bermuda Triangle cluster in the mid-20th century, a period of normal to above normal hurricane activity. What the sediment record tells us is that the ocean has always been this way, and sometimes worse. The bioluminescence of the deep water in the Puerto Rico Trench and the surrounding western Atlantic is one of the biological features of the region that deserves more attention than it receives. The deep water of the tropical Atlantic, like deep water everywhere, is populated by organisms that produce their own light. The mesopelagic and bathypelagic zones of the western North Atlantic contain lanternfish, hatchetfish, dragonfishes, and dozens of other species that produce bioluminescent flashes, glows, and patterns. The function of this bioluminescence varies by species. Counter-illumination to conceal silhouettes against downwelling light, lures to attract prey, signals to find mates, startling flashes to confuse predators. In the absolute darkness below the mesopelagic zone, in the deep water of the Puerto Rico Trench itself, bioluminescence is the only light that has ever existed. The organisms that produce it are the only illumination in a volume of water that extends for 8,000 meters from the surface to the floor in a trench that has been dark for as long as it has existed. The Atlantic at depth glows faintly and intermittently with the chemistry of life, a light show that no human being has ever witnessed except from inside a submersible, and that has been occurring continuously since before the first human being existed. The Bermuda Triangle contains one of the deepest expressions of this phenomenon on Earth, in water that has been glowing with life since long before the legend existed. The coral ecosystems of the Caribbean and Western Atlantic represent one of the most biologically diverse marine environments on Earth, and they sit directly within the boundaries of the Bermuda Triangle. The warm, shallow waters of the Bahamas and the Caribbean that form the western portion of the triangle support coral reef systems that have been building for thousands of years, accumulating the calcium carbonate skeletons of successive generations of coral colonies into structures of considerable size and complexity. The Great Bahama Bank, the shallow carbonate platform that underlies the Bahamas archipelago, is one of the largest carbonate depositional environments in the world, a geological record of reef-building organisms that extends back tens of millions of years into the Cenozoic. The reefs that grow on its edge today are the current expression of a process that has been operating here since long before the Bermuda Triangle legend existed, long before human beings existed. Since the Eocene epoch, when the Caribbean Sea took its current configuration and the conditions for tropical coral growth were established, the connection between these shallow reef systems and the deep water of the Puerto Rico Trench is not merely geographical, it is biological and chemical. The coral reefs produce enormous quantities of organic matter, both in the form of the living organisms themselves and in the carbonate skeletons they leave behind when they die. This organic matter enters the water column and eventually makes its way through the food web and through physical transport toward the deep. The carbonate skeletons dissolve as they sink below the carbonate compensation depth, the depth at which the pressure and cold make calcium carbonate thermodynamically unstable, releasing the calcium and carbonate ions back into solution and modifying the chemistry of the deep water. The living communities of the deep, the organisms of the Puerto Rico Trench, are chemically connected to the coral reefs of the Bahamas and the Caribbean by these cycles of production and dissolution that operate over timescales of decades to centuries. The triangle is not a collection of separate environments, shallow and deep, tropical and abyssal. It is an integrated system, from the sunlit reef to the floor of the Milwaukee Deep, connected by the circulation of water and the rain of organic matter and the chemistry of carbon in the ocean. The Sargasso Sea occupies the interior of the North Atlantic subtropical gyre, a region of the ocean bounded on all sides by ocean currents rather than by land, and a significant portion of it overlaps with the Bermuda Triangle. The Sargasso Sea is named for the sargassum seaweed that accumulates there in floating mats, carried by the gyre circulation and concentrated by the convergence of currents. These sargassum mats are not merely floating vegetation. They are entire ecosystems, supporting a community of organisms that are found nowhere else on Earth. Species that have evolved specifically to live in and on the sargassum, with camouflage and body shapes adapted to blend into the weed. The Sargasso Sea is also the spawning ground of both the American eel and the European eel, two species that migrate from their freshwater and coastal habitats to the Sargasso to reproduce and die, their larvae drifting back to the continents on the currents. The Sargasso Sea is one of the most unusual marine environments on Earth, and it sits partly within the Bermuda Triangle's boundaries. The legend has never mentioned it. The legend has never mentioned most of what makes the triangle scientifically interesting, because the legend was not constructed to inform. It was constructed to mystify. What lies in the deep water of the Bermuda Triangle, from the mesophotic reefs at the edge of the Bahamas platform to the hadal floor of the Puerto Rico Trench, is a progression of environments of increasing extremity and increasing strangeness, each one poorly understood, each one capable of surprising researchers whenever they spend sufficient time and resources investigating it. The deep scattering layer, the dense aggregation of mesopelagic organisms that migrates vertically through the water column every day, is present throughout the Bermuda Triangle region. At night, sonar operators on research vessels in the triangle detect a dense layer of echoes rising toward the surface as the organisms ascend to feed. By day, the layer descends again. This daily migration, one of the largest movements of biomass on Earth, happens in the Bermuda Triangle every day, entirely unremarked by the legend, unnoticed by the cruise ships and pleasure craft that cross the surface above it. The real Bermuda Triangle is not a place where the rules of physics are suspended. It is a place where the rules of biology operate in ways that are genuinely extraordinary, in depths that we have barely begun to explore. And the cases that built its legend, stripped of embellishment and examined honestly, tell a story about the ocean that is more informative than anything the myth ever offered. But there's still one more layer to examine. Not the cases, not the geology, not the biology. The story of why the legend itself persists, and what it tells us about the human relationship with the unknown. Why does the Bermuda Triangle legend persist? This is not a trivial question. The factual case against the triangle as an anomalously dangerous region has been available in the public domain since 1975, when Kuschip published his systematic rebuttal of Berlitz. The Lloyds of London and U.S. Coast Guard positions have been consistent and publicly stated for decades. The statistical evidence that the triangle is not unusual is not hidden in academic journals. It has been available to anyone who looked for it. And yet, the legend has not died. It has continued to circulate, to inspire books and documentaries and films and conspiracy theories, to provide a framework that millions of people find compelling enough to repeat and share. The persistence of the Bermuda Triangle legend in the face of its debunking is itself a phenomenon worth understanding, because it tells us something important about the human relationship with mystery, with the ocean, and with the limits of the known. The human brain is a pattern recognition machine. It was built by evolution in an environment where the failure to detect a pattern, to see the predator in the tall grass or the storm in the shape of the clouds, could be fatal. The cost of a false positive, of seeing a pattern that was not there, was low. The cost of a false negative, of missing a pattern that was there, could be death. Natural selection therefore produced brains that are strongly biased toward pattern detection, that will find patterns in random data, that will construct narratives connecting unrelated events, that will identify agency and intention in phenomena that have no agency and no intention. This cognitive architecture, which served our ancestors well on the savannah, produces systematic errors in domains where randomness and complexity are the actual drivers. The ocean is one of those domains. Deaths at sea, disappearances of ships and aircraft, losses of life in storms and navigational errors and equipment failures are not random in the sense of being equally distributed across space and time. They cluster in heavily trafficked regions, in bad weather, at the limits of technology, in conditions of poor visibility and high stress. When those clusters occur in a geographically identifiable region, the pattern-detecting brain constructs a story. The Bermuda Triangle is that story. The role of the ocean in human psychology is not incidental to the legend's persistence. The ocean represents, in virtually every human culture, the boundary of the known world, the domain of the other, the place where normal rules do not apply. Maritime mythology in every tradition features monsters, gods, mysterious forces, and capricious fate. The ocean is the oldest symbol of the unknowable, predating recorded history by the full span of human existence. The Bermuda Triangle legend arrived in the popular imagination at a particular cultural moment, the 1970s, when the space age had made the universe seem knowable, and when the counterculture's interest in the paranormal was reshaping the boundaries of what educated people considered credible. The triangle fit perfectly into a cultural moment that was simultaneously impressed by science and suspicious of its completeness, that wanted to believe that the rational map of the world had gaps in it, that there were places where the known gave way to the genuinely unknown. The ocean, always the symbol of that boundary, provided the location. The disappearances provided the evidence. Berlitz provided the narrative. The economics of mystery are also relevant. Mystery sells. It sells books, documentaries, television programs, merchandise. The Bermuda Triangle has been a commercially successful mystery for more than 50 years, generating revenue for publishers, broadcasters, and content creators in a way that the mundane explanation, human error, bad weather, the Gulf Stream, the Puerto Rico Trench cannot. The mundane explanation is accurate. It is not dramatic. It does not suggest that the universe is more interesting than it appears. It does not promise revelation or hidden knowledge. The mystery narrative offers all of these things. And in a media environment where attention is the primary currency, mystery consistently outperforms accuracy. This is not a new phenomenon. It is as old as storytelling, but it has been amplified by the economics of mass media in ways that have given the Bermuda Triangle legend a staying power that no amount of factual debunking has been able to overcome. The psychological concept of proportionality bias is also relevant here. Human beings tend to assume that large events have large causes. A disaster that kills hundreds of people, a ship that vanishes without trace, an aircraft that disappears over open ocean feels like it should have a cause proportional to its scale. The explanation that a ship carrying hundreds of people sank because of a combination of mechanical failure, overloading, and bad weather seems inadequate to the scale of the loss. The explanation that 14 men died because their flight leader made a navigational error seems inadequate to the tragedy. There is a psychological pressure to find a cause that matches the magnitude of the effect, and ordinary causes, human error and bad weather and the depth of the ocean, do not feel large enough. The mysterious force, the anomalous zone, the unexplained phenomenon, provides a cause of appropriate magnitude. It satisfies the proportionality intuition even as it abandons the proportionality of evidence. The Bermuda Triangle has also benefited from a peculiar inversion in the way debunking is perceived. In the popular imagination, the person who claims that something mysterious is happening is taking a risk, putting their credibility on the line, going out on a limb. The person who says it is all explained by mundane causes, is playing it safe, defending the establishment, protecting orthodoxy. This framing makes the mysterious claim seem brave, and the mundane explanation seem timid, when in fact, the opposite is often true. The claim that the Bermuda Triangle is supernaturally dangerous is easy to make and essentially impossible to falsify. The claim that it is not anomalously dangerous is a testable empirical claim, one that Lloyd's of London and the U.S. Coast Guard have tested against extensive data and found to be correct. The testable claim, the one that requires evidence, the one that has been tested, is dismissed as the timid orthodoxy. The untestable claim, the one that requires no evidence, the one that cannot in principle be refuted, is celebrated as the brave heterodoxy. This inversion is a feature of the cultural landscape of the paranormal, not a feature of epistemology or evidence. What the Bermuda Triangle legend ultimately reveals about human psychology is something that extends well beyond this particular region of the Atlantic. It reveals that mystery is not merely the absence of explanation. It is a positive quality that people seek out and value, that provides something that explanation does not, a sense of wonder, a sense of scale, a sense that the universe is larger and stranger than the rational framework can contain. The Bermuda Triangle offers this sense of scale in a package that feels grounded and specific, a real place with real coordinates that you can point to on a map where real things have really happened. It is not pure fantasy. It is anchored in geography and in genuine loss, and that anchoring is what gives it its staying power. The ocean is real. The disappearances were real. The grief of the families of the lost was real. The legend appropriates these real things in service of a narrative that is not real, and the appropriation is so thoroughly accomplished that the real things and the narrative have become inseparable in the popular mind. Separating them again requires exactly the kind of patient, systematic, evidence-based work that Kusha did in 1975, and that science does continuously in every field where myth and evidence compete. It is work that is never fully finished, because myths do not die when they are refuted. They persist, they adapt, they find new audiences. The Bermuda Triangle will outlast this documentary, and every documentary made before it, and probably every documentary made after it. The ocean is patient. Myths are patient too. The geography of the Bermuda Triangle intersects with the geography of one of the most consequential chapters in human history, the Atlantic slave trade. The Western Atlantic shipping lanes that the triangle encompasses were among the most heavily traveled routes in the world during the 3 centuries of the transatlantic slave trade, from the mid-15th century to the mid-19th. Ships carrying enslaved people crossed the triangle in the Middle Passage, the crossing from West Africa to the Americas that killed an estimated 1.8 to 2.4 million people in the holds of ships through disease, violence, and deliberate murder. Some of those ships sank. Some of those people drowned. The floor of the Western Atlantic contains the physical remains of this history, the hulls of slave ships, the bones of the people who died aboard them, lying on the seafloor in a region that the Bermuda Triangle legend has transformed into an entertainment product. The archaeology of the Atlantic slave trade is a serious academic field, and the identification, documentation, and preservation of slave shipwrecks is an ongoing project. The Bermuda Triangle legend has never engaged with this dimension of the region's history, because the commercial mythology of the triangle requires a particular kind of mystery, one that is thrilling rather than harrowing, that invites wonder rather than grief. The real history of the Western Atlantic is more important and more disturbing than anything the legend contains. The oceanographic significance of the Bermuda Triangle region extends to the current moment in ways that connect it directly to the global climate crisis. The Western North Atlantic, including the area of the Triangle, is one of the primary regions where the Atlantic meridional overturning circulation, commonly known as AMOC, forms its deepest waters. AMOC is the large-scale ocean circulation pattern that transports heat from the tropics to the North Atlantic and drives the deep water formation that feeds the global thermohaline circulation. Without AMOC, the climate of Northern Europe would be dramatically colder, and the global distribution of heat and precipitation would shift in ways that would affect agriculture, water supplies, and sea levels across the planet. Recent research has shown that AMOC has been weakening over the past century, and possibly longer, in response to the warming of the North Atlantic by climate change. The fresh water from melting Arctic ice and Greenland ice sheets is reducing the salinity and density of the surface water that needs to sink to drive AMOC, potentially disrupting the circulation that has regulated the climate of the North Atlantic for thousands of years. The Bermuda Triangle sits in one of the most climate-sensitive regions of the ocean, a region where the physical processes that regulate the global climate are currently undergoing changes whose consequences are not fully known. This is not the mystery the legend describes, but it is a genuine mystery, a scientific uncertainty with profound implications that the water of the Bermuda Triangle is directly involved in. The history of human encounters with the ocean in the Bermuda Triangle region goes back at least 10,000 years to the indigenous peoples of the Caribbean and Florida coast, who navigated these waters in dugout canoes and sailing craft. The Lucayan people of the Bahamas, the Taino of the Greater Antilles, and the Calusa of Florida all had maritime cultures that depended on knowledge of the currents, the winds, the seasonal weather patterns, and the underwater topography of the Western Atlantic. This knowledge, accumulated over generations, was largely destroyed by the European colonization of the Caribbean that began in 1492. The Lucayan people were enslaved by the Spanish within decades of contact. The Taino were effectively destroyed within a century. The Calusa survived longer, but were ultimately displaced by the expansion of European settlement into Florida. The maritime knowledge these cultures had accumulated about the Western Atlantic, including detailed empirical knowledge of the Gulf Stream, the seasonal storm patterns, and the navigational hazards of the region, was lost with them. This loss of indigenous knowledge is itself a form of mystery, a gap in the human record of the ocean that no amount of oceanographic research can fully replace. The Bermuda Triangle legend, which dates its story of the region from the mid-20th century, erases 10,000 years of human relationship with these waters. The island of Bermuda itself is one of the most geologically peculiar places in the Atlantic. It is a volcanic seamount built up from the floor of the Atlantic over the Bermuda hotspot, a region of anomalously hot mantle that produced a series of volcanic eruptions approximately 33 to 45 million years ago. The volcanoes that built Bermuda have been extinct for tens of millions of years. What remains is an eroded volcanic platform capped with a thick layer of Aeolian limestone, wind-blown calcareous sediment that was deposited on the volcanic surface during glacial periods when sea levels were lower. The result is an island of white limestone perched on a submerged volcanic seamount in the middle of the North Atlantic, surrounded by the northernmost coral reef system in the world. Bermuda's latitude, approximately 32 degrees north, is too far north for tropical corals under normal circumstances. But the Gulf Stream carries warm water northward past the island, raising the water temperature enough to sustain a reef system that would not otherwise exist at this latitude. Bermuda is therefore a biological outpost, a place where tropical marine life exists far beyond its normal range because of the same current that makes the Bermuda Triangle so dangerous for navigation and so difficult for searches. The island is beautiful. The reef is extraordinary, and both exist because of the Gulf Stream, the same force that has carried so much of the Triangle's tragedy out of reach. The light at Bermuda is also distinctive and has attracted artists and scientists alike for centuries. The combination of the white limestone of the island, the clear water of the surrounding ocean, and the angle of the subtropical sun produces an intensity and quality of light that is unlike anything found at higher latitudes. The Bermuda waters are some of the clearest in the Atlantic, their low nutrient content producing the transparency that makes them brilliant blue rather than the green or gray of more productive waters. That clarity extends to considerable depth. Light penetrates deeper in the Bermuda waters than in most of the Atlantic, sustaining the mesophotic coral ecosystems that grow on the deeper reef slopes below the range of typical recreational diving. These mesophotic reefs, found at depth of 30 to 150 meters, are one of the most poorly understood coral reef environments in the ocean. They are too deep for easy access by scuba divers and too shallow for the submersibles typically used for deep-sea research. They exist in a depth gap in the survey record, studied less thoroughly than either the shallow reefs above or the deep-sea communities below. Recent advances in closed-circuit rebreather diving and in the use of research submersibles designed for mid-depth operations have begun to fill in this gap, revealing coral reef communities of considerable diversity at depths that were previously unsurveyed. The mesophotic reefs of Bermuda are one of the more promising frontiers in Atlantic marine biology, and they sit at the northern vertex of the Bermuda Triangle, in a location where the legend has never thought to look. The relationship between the Bermuda Triangle and the broader Atlantic Ocean system is one of integration rather than isolation. The triangle is not a sealed zone. It is a region of open ocean that exchanges water, organisms, and energy with the rest of the Atlantic on every timescale from hours to millennia. The Gulf Stream carries water from the Gulf of Mexico through the triangle and northward toward Europe, connecting the western Atlantic to the eastern Atlantic and to the waters around Greenland and Iceland. The deep water that fills the Puerto Rico Trench arrived from the North Atlantic thousands of years ago and will eventually upwell in the tropical Atlantic hundreds of years from now. The organisms that live in the sargassum mats of the Sargasso Sea are distributed by the gyre across the wider North Atlantic when storms break up the mats and scatter the weed. The migratory species that cross the triangle, the whales, the sea turtles, the bluefin tuna, the eels, connect its waters to distant parts of the ocean through the trajectories of their lives. The triangle is a place, but it is not a closed system. It is a window into the Atlantic, and the Atlantic is a window into the ocean as a whole. What happens in the triangle matters beyond the triangle's boundaries. The legend never grasped this. The legend reduced the triangle to a stage for disappearances, stripping it of its connections and its context. The real triangle is more connected than anything the legend imagined and more consequential, and what those connections ultimately mean for the science of the ocean and for the future of the planet is what the final part of this descent is about. The Bermuda Triangle is a story about the ocean, not the ocean of the legend, which is a stage for disappearances and a backdrop for mystery. The actual ocean, the physical and biological reality of the western North Atlantic, with its currents and its depths and its creatures and its geological history, that ocean is extraordinary. It is extraordinary in ways that the legend never captured, in ways that require no embellishment and no supernatural explanation, in ways that are, if anything, more astonishing than anything Berlitz or his predecessors imagined. The real Bermuda Triangle contains one of the deepest points in the Atlantic Ocean, a living reef at latitudes where reefs have no right to exist, a sea bounded not by land but by currents, migratory corridors for some of the most ancient and remarkable animals on Earth, and a circulation system whose health is directly connected to the climate stability of the entire northern hemisphere. The legend gave us disappearances. The reality gave us the ocean. The ocean is better. The Gulf Stream's role in the climate of the North Atlantic is one of the most consequential facts in Earth science, and it passes through the heart of the Bermuda Triangle. The current moves approximately 150 times more water than the Amazon River. It carries heat from the tropics northward at a rate that warms the climate of Western Europe by several degrees relative to what it would be without the current. Without the Gulf Stream, London would have the climate of Labrador. Paris would have the climate of Quebec City. The wine regions of France and Germany would not exist. The agricultural productivity of Northern Europe that has sustained dense human populations for thousands of years would be dramatically reduced. All of this, the warmth of London winters and the vineyards of Burgundy and the livability of Scandinavia, depends on a current that passes through the Bermuda Triangle. The triangle is not merely a region of the ocean, it is a component of the climate system of the Northern Hemisphere. What happens in its waters, and what we do to those waters, matters in ways that extend far beyond the triangle's boundaries. The bluefin tuna, Thunus thinnus, is one of the great migratory animals of the Atlantic, and its migratory path passes directly through the Bermuda Triangle. The western Atlantic population of bluefin tuna spawns in the Gulf of Mexico and the western Caribbean, juvenile fish growing in the nutrient-rich waters of the eastern seaboard and the North Atlantic, and adults crossing the ocean to feed in the rich upwelling areas off the coast of Europe and North Africa before returning to their spawning grounds. The triangle sits at the intersection of the outbound and inbound legs of this migration. Bluefin tuna passing through the triangle do so as part of a circuit that has been running for millions of years, long before the legend existed, long before human beings began fishing the Atlantic. The bluefin is one of the most remarkable animals in the ocean, capable of regulating its body temperature above the ambient water, allowing it to function in cold water that would paralyze most fish. It can reach speeds of 70 kilometers per hour. It can cross the Atlantic in less than 2 months. It is a fish that operates at the physical limits of what vertebrate biology permits, and it passes through the Bermuda Triangle twice a year, unremarked by the legend, unnoticed by the mythology, simply moving as it has always moved through water that has no idea it is supposed to be mysterious. The loggerhead sea turtle, Caretta caretta, follows a migration that is among the longest of any reptile on Earth, and part of that migration passes through the Bermuda Triangle. Female loggerheads nest on the beaches of Florida and the southeastern United States, and the hatchlings that emerge from those nests enter the Atlantic and are carried by the Gulf Stream northward and then eastward, riding the current across the North Atlantic to the coast of Europe and North Africa, where they spend years growing before eventually finding their way back to their natal beaches to nest. This return journey, crossing the open Atlantic in both directions, takes the turtles through the Bermuda Triangle multiple times in the course of a single reproductive life. Loggerheads navigate using the Earth's magnetic field, imprinting on the magnetic signature of their natal beach, and using the variation in magnetic intensity and inclination across the ocean as a geomagnetic map. This navigation system allows them to find their way across thousands of kilometers of featureless ocean to within a few kilometers of the beach where they hatched. The Bermuda Triangle, with its variable magnetic field, is a region that sea turtles have been navigating successfully for millions of years. The magnetic complexity that the legend attributes as a cause of human disappearances is, for the loggerhead, simply a familiar feature of the route home. The sperm whale population of the North Atlantic ranges through the Bermuda Triangle, as part of its foraging movements in the western Atlantic. Sperm whales are deep divers, descending to 2,000 meters or more in pursuit of the giant squid and other large cephalopods that make up the majority of their diet. In the Bermuda Triangle region, the deep water of the Puerto Rico Trench and the surrounding abyssal plain provides habitat for the squid and other prey that sperm whales depend on. And the whales have been recorded in these waters by acoustic monitoring programs that detect the whales' distinctive clicks as they navigate and hunt. A sperm whale diving to 2,000 meters in the Puerto Rico Trench region descends through the same water column that Flight 19 likely ditched into 80 years ago, through the same Gulf Stream that carried the debris of those aircraft away from the searchers, through the same darkness that the legend has always used as a backdrop. The whale does not know about the legend. The water does not know about the legend. Only the human beings looking at the surface know about the legend, and the legend tells them nothing true about what is beneath it. The acoustic environment of the Bermuda Triangle is one of its most striking and least discussed physical properties. The western North Atlantic is one of the noisiest parts of the ocean, not because of anything mysterious, but because of the concentration of biological activity and shipping traffic. Humpback whales produce complex songs that propagate for hundreds of kilometers through the water column, songs that have been recorded in the triangle since acoustic monitoring of the North Atlantic began in earnest in the mid-20th century. Sperm whales produce clicks that are among the loudest sounds made by any animal, detectable at ranges of several kilometers by passive acoustic monitors. The Sargasso Sea, which overlaps with the triangle, is one of the few places in the North Atlantic where snapping shrimp are present in sufficient quantities to produce the crackling background noise associated with shallow reef environments, adding a biological soundtrack to a region of open ocean that would otherwise be acoustically quieter. And beneath all of this, the shipping traffic of the Western Atlantic adds a continuous, low-frequency hum that has been detectable on underwater hydrophones for as long as industrial shipping has crossed the Atlantic. The Bermuda Triangle is acoustically rich, biologically, geologically, and industrially. The silence that the legend implies, the mysterious absence of communication, the inexplicable disappearance into a void, is not the acoustic reality of the region. The nutrient chemistry of the Bermuda Triangle region reflects the larger patterns of the subtropical North Atlantic gyre. The gyre interior, which includes the Sargasso Sea and the Central Triangle, is one of the least productive parts of the ocean, a marine desert in biological terms, its surface depleted of the nitrogen and phosphorus that phytoplankton need to grow. This nutrient depletion is a consequence of the gyre circulation itself, which concentrates water in the center and prevents the upwelling that would bring nutrients from the deep. The productivity of the Western Atlantic increases dramatically at the edges of the gyre, where the Gulf Stream generates turbulence that mixes nutrients into the surface layer and at the margins of the continental shelf, where upwelling brings cold, nutrient-rich water to the surface. The spatial gradient of biological productivity across the triangle, from the nutrient-poor Sargasso in the interior to the productive shelf waters in the west, is reflected in everything from the distribution of fish to the concentration of plastic debris that accumulates in the gyre, and the kind of marine snow that sinks toward the Puerto Rico Trench from above. The biological desert of the Sargasso Sea and the biological richness of the Gulf Stream margins exist side by side within the triangle's boundaries, separated by a few hundred kilometers of latitude, each one a distinct ecological world shaped by the same large-scale circulation that makes the triangle what it is. What does the Bermuda Triangle mean in the end? Not the legend, not the disappearances, not the mystery, not the manufactured narrative that Berlitz assembled and the entertainment industry perpetuated. What does this specific region of the western North Atlantic mean as a physical and biological and geological reality? It means that the ocean is extraordinary in ways that do not require embellishment. It means that a patch of water covering at most 1.5 million square kilometers can contain the deepest point in the Atlantic, a coral reef that should not exist at its latitude, the spawning ground of animals that cross oceans, a current that warms continents, a circulation system that regulates the climate of the hemisphere, and a geological boundary that has been shaping the Caribbean for 40 million years. All of this in a region that most people know only as the place where ships and aircraft supposedly vanish into the unknown. The ocean has been offering the real story all along. The legend simply got there first and told a different one. Let that settle now as you drift toward sleep into the dark water below the triangle's surface, past the mesopelagic creatures rising toward the night, past the cold water of the deep Atlantic moving southward along the floor, past the silence where the Milwaukee Deep begins its 8,000-meter descent. The triangle is there, in the dark, in the water, patient and indifferent, and full of things we have not yet found. It has been there for 40 million years. It will be there long after the legend is forgotten, and long after everyone who ever repeated the legend is gone. The whale shark, Rhynchodon typus, is the largest fish in the ocean, reaching lengths of up to 18 meters, and it passes through the Bermuda Triangle on its seasonal migrations through the western Atlantic. Whale sharks are filter feeders, consuming enormous quantities of zooplankton, fish eggs, and small fish by swimming open-mouthed through concentrations of prey. They aggregate at predictable locations and times throughout the tropics and subtropics, following the productivity pulses that the ocean's seasonal cycles produce. In the western Atlantic, whale sharks have been documented in the Gulf of Mexico, the Caribbean, and the waters of the Florida Straits, all of which lie within or adjacent to the triangle's boundaries. Their migrations take them through the same waters where the Gulf Stream concentrates nutrients and organisms along its edges, through the same warm surface layer above which the legend plays out its drama of disappearances. The whale shark is one of the most ancient of the shark lineages, its body plan essentially unchanged for tens of millions of years. It has been swimming through these waters since before the Gulf Stream took its current path, since before the Puerto Rico Trench reached its current depth. It knows nothing of the legend. It knows the temperature of the water and the smell of prey and the pull of the current. Everything else is human construction. The deep scattering layer of the Bermuda Triangle region has been studied more extensively than that of most parts of the Atlantic, partly because of the triangle's location along major shipping and research vessel routes, and partly because of the long history of acoustic research in the western North Atlantic associated with Cold War naval monitoring programs. The DSL, as it is known, is a layer of mesopelagic organisms that migrates vertically through the water column every day, ascending toward the surface at night to feed and descending again by day. On sonar, it appears as a dense reflective layer that moves between depths of several hundred meters during the day and the surface at night. The organisms that make up the DSL in the Triangle region include lanternfish of multiple species, various crustaceans and gelatinous organisms, and squid. Their daily migration moves enormous quantities of carbon from the surface to the deep, as the organisms feed at the surface and excrete and die at depth, carrying with them the organic carbon they consumed. The biological pump of the Bermuda Triangle, the process by which the region's surface productivity is transferred to the deep ocean, is partly driven by the daily commute of the DSL's inhabitants. Every night, millions of small animals rise through the water column of the triangle to feed. Every day, they descend again, carrying the triangle's productivity with them toward the deep. The history of scientific research in the Bermuda Triangle region is longer and richer than the legend suggests. The Challenger expedition of 1872 to 1876, the first systematic oceanographic survey of the world's oceans, passed through the western North Atlantic and conducted soundings and water sample collections in the Triangle region. The Challenger's crew measured depths, collected sediment samples, and documented species from the bottom that had never been seen before. The data from the Challenger expedition, compiled into the 50-volume Challenger reports, included observations from the Bermuda Triangle region that were foundational to the developing science of oceanography. By the time Vincent Gaddis coined the term Bermuda Triangle in 1964, the region had already been the site of serious oceanographic research for nearly a century. The Bath Station, established near Bermuda in 1988, has generated one of the longest continuous records of ocean chemistry in the world. The acoustic monitoring programs of the U.S. Navy, which were designed to detect Soviet submarines during the Cold War, but which incidentally recorded the sounds of whales and geological events throughout the North Atlantic, produced a decades-long acoustic record of the Triangle region that is now being analyzed by marine biologists and oceanographers for the information it contains about the region's biology and geology. The Bermuda Triangle has been studied. The studying has revealed an ocean, not a mystery, and the ocean is far more interesting than the mystery ever was. The ocean around Bermuda holds one more secret that belongs in this account. The question of what happened to the aircraft and ships that the legend claims were taken. In many cases, the answer is known. The aircraft ditched in heavy seas and sank rapidly. The ships foundered in storms. The wrecks lie on the seafloor, displaced from their last known positions by the Gulf Stream, scattered by bottom currents, slowly being processed by the bacterial communities and the biological activity that constitute the deep-sea food web. Some of those wrecks have been located by side-scan sonar surveys conducted in recent decades. Some remain unfound, not because supernatural forces concealed them, but because the ocean floor of the western North Atlantic is enormous. The search resources available are limited, and the Gulf Stream moved the debris of most incidents far from where the accidents occurred. The puzzle of the missing wrecks is a logistical puzzle and an oceanographic puzzle. It has been partly solved by systematic survey work. It will be further solved by the continued improvement of deep-sea survey technology. The mystery is not permanent. It is shrinking, one wreck found at a time, one sonar survey at a time. As the tools available to search the seafloor become more capable and the archives of the Legends cases are re-examined with fresh eyes and better instruments, the triangle is losing its mystery. Not because the ocean is being tamed, but because the ocean is being understood. And understanding, it turns out, is more interesting than mystery ever was. The ocean does not need the story. It has the reality, and the reality is enough. Rest now. Let the depth hold you. If this journey moved something in you, consider subscribing to Sleep on Deep. Every week, we descend a little further. The ocean is waiting.